This video is for lesson 4-1, segments and midpoints. This is the first lesson in activity 4, which is about measuring how long segments are and measuring how large angles are. Learning goals are to apply the segment addition postulate to find the length of segments and to use the definition of midpoint to be able to find the length of segments. In geometry, axioms, which are also called postulates, are statements that are accepted to be true without having to prove them. To measure how long something is, we use a tool called a ruler, and we use the ruler postulate to define distance along a straight line. In the picture that you see on the screen, from A to B, if we put the ruler on there so that the 0 mark is located at A and the 5 inches mark is located at B, we define the distance from A to B to be 5 units because 5 subtract the starting point of 0 makes 5 units. In general, to find the distance between points on a line using a ruler, you take the ending number and subtract the beginning number. Make sure that that answer turns out to be positive, and if needed, you can use absolute value bars to make sure that the answer is positive, and you'll have the distance. On the bottom picture on the screen, point A is located at 2 on the ruler, point B is at 7. The distance between them is still 5 inches because 7 subtract 2 is 5. In this lesson, we may have some drawings of segments where you're asked to use an actual ruler to find distances. I can't show this easily by a video because I can't put a ruler on the screen, and so we're going to have to skip question 1. But in general, when you see two capital letters side by side, that means the length from D to E. Or if you want to say this, the distance from D to E, you would find that distance by putting a ruler starting at D, figuring out what number is located where E is, and then subtracting those two numbers. Number 3, use our previous results to describe any patterns that you notice. For problem 2, let me tell you what the answers are on a ruler. From K to H is 4.9. I'm going to go up in the drawing and label that as 4.9. So this piece here is 4.9 centimeters. From H to G is 5.7. Let me label that up in the drawing. So 5.7 from the G across to the H. From G to K, that is the entire distance all the way across there, is 10.6. What patterns do you see? I hope that the pattern that you see is that if you add these two distances, that is equal to 10.6, the total distance. So let's describe that for number 3. One way to write that is like this. The sum of the shorter lengths is equal to the total length. Now, you don't have to write that down in your notes because we're going to write that later on and call it a postulate. Number 4, given that N is a point between endpoints M and P of line segment MP, describe how to determine the length of segment MP without measuring. If we're given the lengths of segment MN and segment NP, there's a lot of information here. Let's draw what this is talking about so we can understand it a little bit better. It says that we have line segment MP. I'm going to draw that. Here is one dot stretching over to another dot. This is M and this is P. Here is line segment MP. It says that N is a point between these dots. Somewhere in between them, I'm going to put a dot and call it N. The question asks us, how could we determine the entire length from M to P if we knew that length and we knew that length? Do you see that you could add those two together and that would equal the total length? Writing that in symbols, length MN plus length NP is equal to length MP. The two shorter pieces is equal to the total length. That problem and problem 3 right before illustrate what segment addition means. What does it mean to add two segments together? So number 5, use the segment addition postulate and the given information to complete the statement. Question A, if B is between C and D, and BC is 10 inches, and BD is 3 inches, then how long is CD? For a problem like this, it helps to draw what this is talking about. We're told B is between C and D. Let's make a quick sketch of that. It doesn't have to be perfect or anything. We just want to know visually what's going on. So we have C and D. We're told B is between there. So somewhere between them, I'm going to put B. We're told that BC is 10 inches. So from B to C, this first piece, label 10. We're told that BD is 3. So in between B and D, that shorter piece, label 3. How long is CD? With the segment addition postulate, we know to add the two shorter pieces to find the total distance. We can get that this is 13 inches. Hopefully you see that drawing the picture helps you see why it's 13 inches, the 10 plus the 3. Question B, if Q is between R and T, and we have some other information, find QT. Let's draw this. We have point R stretching over to point T. We're told that Q is between them, so somewhere in between them, I'm going to locate point Q. I'm purposely not putting it exactly in the middle because nothing in the directions told me it was exactly in the middle. From R to T, it's 24. So that entire distance all the way across, I'm going to label 24. QR is 6. So between R and Q, label 6. How far is QT? If the entire distance is 24 and this short piece is 6, 6 plus what missing number makes 24? And we can find out that that has to be 18 centimeters. Question C is very similar, but it's going to have some algebra expressions. P is between L and A. Let's draw that. Drawing a quick sketch helps us get the letters in the right order. So we have L and A. P is between them, so somewhere in between them, locate point P. Sorry about the little dip right there. From P to L is x plus 4. So this little piece here, x plus 4. From P to A is 2x minus 1. That's this piece. From L to A is 5x minus 3. So the entire distance gets labeled 5x minus 3. Let's figure out what x is equal to and then figure out length LA. With the picture, we can tell what the two short pieces are that sum together to equal the total. And then we can write an equation. X plus 4 plus, and now this other piece here, 2x minus 1, is equal to the total length all the way across, which is the 5x minus 3. Here's an algebra equation. Let's solve for x. X plus 2x is 3x. 4 and minus 1 is a positive 3. So on the left side of the equals, I combined some like terms. Next step, let's subtract 3x from both sides to get 3 equals 2x minus 3. Then add 3 to both sides to get 6 equals 2x. Therefore, x equals 3. That was one of the things we were asked to figure out. So up here on the line, x is 3. We can fill that in. Now we're asked to find length LA. Well, the algebra expression for length LA is 5x minus 3. So there's where the x is that we're going to substitute the value of 3. 5 times 3 is 15, subtract 3 is 12. So length LA turns out to be 12 units. I'm going to pause the video here, and I'd like you to copy down all of the work that was done for question C. Algebra can be kind of tough, so if you copy this all out, you'll have a sample problem with the algebra. Next, let's switch to the topic called midpoint, or the middle point of a segment. The midpoint of a segment is the point on the segment that divides it into two congruent segments. For example, B is the midpoint of segment AC, and segment AB is congruent to segment BC. The symbol with the equal and the little squiggle is the symbol for congruent, which means equal length. So in this drawing, we're saying point B is exactly in the middle between A and C, and that this segment is congruent to this segment. Question 6. Given that M is the midpoint of segment RS, complete each statement. First of all, let's draw this to help us visualize. So we'll quickly draw segment RS, any length you want to. We're told M is the midpoint. So the best that you can, find the exact middle there and put M. This helps us visualize. Question A, if RS equals 10, then find SM. So RS is 10. The entire distance across there is 10. What's SM? What is it just from the middle over to the edge? That would be 5. Okay, same picture just to save time. Let me erase away question A work and go to question B. If RM is 12, so in our drawing from R to M, that first piece there, that's 12. Then what's MS from here to here? That's also 12. And then what's RS, the distance all the way across? Well, if both pieces are 12, then all the way across is 24. Here are some check your understanding questions. I'll pause the video for you to work on these. Here are the answers. Number 7, points D and E are on a ruler. Point D is marked at the 4.5 centimeter mark, and the distance between D and E is 3.4 centimeters. At what marks could point E be located? 4.5 plus 3.4 is 7.9. That's one possibility. 4.5 subtract 3.14 is 1.1. That's the other possibility. If the other mark was at either of these numbers, then the distance between the dots could be the 3.4. Question 8. Point N is the midpoint of segment FG. I drew that to help me visualize. Fn is 2x. So if this first piece is 2x, then this other one is also 2x. How long is FG? 4x. Number 9, does a ray have a midpoint? No, it doesn't. Only segments can have midpoints. Number 10, give an example to illustrate the segment addition postulate. I made a quick sketch of a segment broken up into two pieces, and if one piece is 2 and the other piece is 8, my picture shows that the entire distance is 10. So here was my example. Number 11, you can also use a number line instead of a ruler to find the distance between 2 points. After all, a number line is simply a ruler drawn on paper with all the marks labeled. Number 11, what is length LM? If one end is at -3 and the other end is at 4, the distance between them can be found by subtracting the starting and final value. Take the last number 4 and subtract the starting number of -3. 4 subtract -3. The double negative is equivalent to a plus sign, and the final answer is 7. And that can be confirmed by counting the units. Start by pointing your pencil at the first dot and count the number of units. 1, 2, 3, 4, 5, 6, 7. We visually confirm that the answer was 7. Let's go back to talking about midpoint. The midpoint of a segment is halfway between the endpoints. So if we know the coordinates of the endpoints, we could average them to find the coordinate of the midpoint. Number 12, what is the coordinate of midpoint M? This is at 8. This is at 40. The middle between 8 and 40 is the average of 8 and 40. To average two numbers, you add them together and divide by 2. So 8 plus 40 is 48, and 48 divided by 2 is 24. I think the midpoint is right there, and I hope that visually you agree that that looks like the midpoint. I'm going to pause this for you to copy down this example problem. Here are some check your understanding questions. I'll pause the video for you to solve these. For question A, what is length KL? The length from -9 to +15. We can count units or use subtraction. 15 subtract -9 is 24. Question B, what is the coordinate of the midpoint of segment KL? This is at -9, this is at +15. To find the middle, average those two numbers. -9 plus 15 and divide by 2. That answer turns out to be 3. So right there at 3 is the exact middle. Now question C. Point C is between K and L. The distance between points K and C is 1/3 of KL. So what is the coordinate of point C? 1/3 of KL. We earlier figured out that KL was 24. So 1/3 of 24 is 8. So knowing that that answer is 8 will allow us to find the coordinate of point C. So if we start at K and we go 8 units across the segment, what number would we end up at? We would end up right there at -1. And there's point C, located at -1, because it's 8 units away from -9. For question D, point N is between points C and L. The distance between points C and N is 3/4 of CL. What's the coordinate of point N? Well, first let's figure out length CL. C is at -1. L is at 15. 15 subtract -1 is 16. It is 16 units from C to L. What's 3/4 of that? So 3/4 of 16. Let's figure that out. 1/4 of 16 is 4. 3 times 4 is 12. 12 units. Okay, start at point C. Go 12 units to the right. What number would you end up at? From -1 all the way to here at 11 is 12 units. Here is where point N is. 12 units to the right of point C. Here are some try these questions. I'll pause the video for you to work on these. Here's the answer to question A. If y is the midpoint of segment WZ and yz is x plus 3 and wz is 3x minus 4, determine the length of segment WZ. I have drawn this picture to help me visualize. I started by drawing segment WZ, putting y exactly in the middle. And then I labeled the values that were given to be. From y to z is x plus 3. The entire distance across is 3x minus 4. Now, if this part is x minus 3, how long is this part? It's also x plus 3, because y is the midpoint. That allows me to make an equation. X plus 3 plus the other x plus 3 is equal to the total distance, 3x minus 4. Let's solve this equation. X plus x is 2x. 3 plus 3 is 6. And that is equal to 3x minus 4. Now subtract 2x from both sides to get 6 equals x minus 4. Now add 4 to both sides to get x alone. and we have 10 is equal to x. Once we know the answer for x, we can find segment WZ. Go back to the picture. From W to Z is all the way across. It's this algebra expression. So this is the one that we fill in 10 for x. 3 times 10 is 30. 30 subtract 4 is 26. This is 26 units. Let's skip question B and C. There is one last vocabulary word in this section, the word bisect. When you bisect a geometric figure, you divide it into two equal parts. Number 14, line segment WZ bisects segment XY at point Z. What conclusions can we draw? It'll help us to draw a picture so we can visualize. So it talks about having segment XY. That's this piece of information. What are we told happens? Line segment WZ bisects it. Bisecting it means go right through the middle. I think that spot right there is exactly in the middle. It doesn't tell us it has to go straight up and down or anything, so I'm going to just draw some random segment that goes through that midpoint and keeps going on the other side. This segment we were told was WZ. Right there. Looks like I drew it a little bit too long. Let me erase that piece off there that I didn't want. So segment WZ, and it stops at point Z. We were told that point Z is the spot where it crosses segment XY. What conclusions can we draw? We can conclude that this is congruent to this. Let's write that out in symbols. XZ is congruent to ZY. Another conclusion that we can draw is that XZ is equal to ZY. In one case, we used congruent to say that the segments were the same. In the other case, we used an equal symbol to say that the lengths were the same. I'm going to pause the video here so you can take notes on this one. Here are some check your understanding questions. I'll pause the video for you to work on these. And here are the answers. Number 15, explain how to find the distance between 2 points on a number line. Up here on the left side is the answer. You subtract the numbers. If one point is located at 2, the other point is at 10, subtract them, 10 minus 2 to get 8. Number 16, Mekki knows that GH is 7 and HJ is 7. So he claims that point H is the midpoint of segment GJ. Is it necessarily true? I think no, because they might not be on the same segment. I tried to draw what I was thinking of. From G to H is 7, and from H to J is 7, but notice that point H is not the midpoint between G and J. In fact, there's not even a segment drawn connecting G over to J. If there was, the midpoint would be kind of right there, not at H. Number 17, T is the midpoint of segment JK, and we have some algebra expressions. I've drawn that, JK, and I put T in the middle, and then labeled the algebra expressions. That way I can tell what the shorter pieces are that add together to make the total. So I went 2x plus 1 plus 2x plus 1 equals 5x minus 3, and solved the equation getting 5 is equal to x. Once I know the answer for x, we can find length jk. Over in the picture, which algebra expression is for jk? It's this one, the 5x minus 3. So that's where you fill in x is 5. 5 times 5 is 25 minus 3 is the answer 22. Last question, number 18. Segment AB is on a number line. The coordinate of point A is at -6. And the distance from A to B is 20 units. So what are the possible answers for point B? If point B is to the right of point A, we can go -6 plus 20 units to see what number it ends up at. That's 14. If point B is to the left of point A, we can start with -6 and subtract 20 units to move to the left, and that would end up at -26. These are the two possible locations for point B. There was a lot of information in this video. The first thing we talked about was the segment addition postulate, which allows us to add two shorter segments together to equal to a longer segment. We did problems that had just numbers with that, and we did some algebra problems with that concept. The next thing we talked about was midpoint, which is the point exactly in the middle of a segment. To find it, you average the endpoint numbers.